Hi guys, welcome to my first tutorial on joins. I'm gonna cover basics. So joins exist to combine data from different tables. Let's say we work for engineering department and we have different circuits. We have two tables. Table 1 and table 2. Both of them have lists of circuits coming from different systems. But the lists are slightly different. So table 1, let me maximize it. Table 1 contains circuit ID, the length of the circuit, and whether the circuit is active or not. And Table 2 also has a list of circuit and it contains voltage of the circuit and whether the circuit is active or not. If you notice, both tables have 4 records. 3 records match on the circuit. It's the same circuit, 101, 102, and 103. But the 4th circuit is unique to each table. So let's say we want to answer the following questions. Let's get the list of all circuits that match between the tables that we have. Let's get the circuits that that can be found in both tables, and we want on the same row we want the length of the circuit and the voltage of the circuit. So that would be using inner join. Now with joins it's very convenient to use aliases. Okay, so what I wrote here is I want to select everything from table 1 with alias T1 and I want to join it to table 2 with alias, with alias T2. But what am I matching the circuits on? I have to specify that in the on clause, which is it's part of the join clause. Well, we're matching on the circuit column. So table 1 circuit equals table 2 circuit. And we got the 3 records, which is the number of circuits or records that match between the two tables. Everything that was unique to each table fell off. Okay, now let's say the question was asked, slightly different question was asked. I want to see everything from, let me show you the Venn diagram first. I minimize it. Okay, so 4 by 6 joins are represented here. This is the inner join. If you noticed, I did not type inner join here. We will get the same result if I do. Because if you omit inner join, if you just type join, it's assumed that it's inner join. It's a default type. So this Venn diagram represents table 1, this circle, and table 2. The blue area is the intersect, the circuits they have in common, and these are the only rows that will be returned by inner join. let's say the question was asked differently. We want to see all circuits from table 1, whether they have match with table 2 or not. And of course, we want to get the additional information, the voltage for those circuits that have match with table 2. And this would be represented by this diagram. So as you can see, we're going to get everything from table 1. The terminology used is table 1 will be preserved. All records will be preserved. And of course, we will, as far as table 2, we will only get the information from it that is matching with table 1. So let's change inner to left. Left join now. The difference. So that Y record, just to remind you quickly, we had Y circuit here, what we didn't have it here, and it will be represented here. As far as what's gonna go to circuit in voltage and all the fields from the table 2, well, there is no information for this circuit there. So it is this the value that's used to fill in these fields is null. And this, as I do my advanced tutorial on joins I'm going to be doing, we'll see that we can use the fact that there are nulls here, especially here in the circuit, to do some really interesting queries. Important point here is that when there is no matching record, all the fields for it will be filled in with null. Okay, so you might want to ask a question, well, if you're new to left joins is, well, what exactly is to the left of what? Does it matter, for example, if the order of fields in the on clause is same? So let me change it. Well, easier to change it like this. So just swap them basically. Let's see if there is any change. No change. So the order of these matching fields is not important. What it's referring to is actually the tables. So the table that's to the left, and this is why I put it on one line, to illustrate that the table on the left is what we're doing the left join on. This is the table that's going to be preserved, while the table 2 is on the right. Now we can do the mirror image of it, the right join. The right join will show you everything that's in table 2, and as far as table 1, it will show you only the records that match with table 2. It's so it's the same idea as left join. It's used much less common, because rather than, if this is what we want, in fact, all the records from table 2, rather than doing right join here, we would keep left join and change the order of the tables. But just for the sake of completeness, let's do right join, and they are used. It's just much less often. May as well see this. Okay, So, well, it looks strange because we're just selecting everything, all the fields. If I was doing something like this, right join here, I would make sure that the fields that are coming from table 2 come before table 1, because really this is what gets preserved. But why is it on the right side and we have nulls here? This just looks weird. It's correct but weird. So at least let's specify, give me everything from table 2 first, and then from table 1. So at least it's in the right logical order. Like this. So the ZZZ circuit was only present in table 2, and we see it. And we have full join, and you can probably guess that everything will be selected by that join. Everything from table 1 and everything from table 2. Copy this instead of changing. Change to over here. Both circuit Y and circuit Z are here. So one thing that's kind of imperfect here, well, let's ask the question, do we really need to show a circuit? I want to cover this. It's not so important, stylistically, but it just gets you thinking in the right way about joins. So let's ask a question about each of those queries that I did. Did I need to select circuit twice? Or is it redundant to select circuit twice? Well, in this case, I would say it's definitely not in case of full join, because we're gonna have some circuits from one table that are not in, we're gonna have some circuits from table 1 that are not in table 2, and the other way around. So if I'm only selecting, if I'm only doing something like this, I'm gonna have something weird, just the half, whole nulls. Maybe a better example would be this. If I listed all the fields here, let me do that. Let me start here. Let's list all the fields. I'm not gonna do active. Let's forget about active now, but just the main fields. Let's start with inner join. So I'm selecting circuit twice from both tables. Of course, if I did just select everything, it would come up twice also. But I just want to be explicit here. Right. I'm selecting everything, have it twice. Okay. Is it redundant or not to select circuit from both tables? We obviously need to select the length from one table and the voltage from another table. Those, for each instance, they're going to have different values. We need to see them. But what about circuit? Well, I would say that it's redundant to select circuit from both tables here, because we will only see the circuits that have the same circuit ID. So in this case, I would omit this. This is how I would do it. Let's move to left join. Let me copy this. Okay. Well, I definitely need to show the circuit here. Let me select this, add the second circuit. Right. So definitely need a circuit from table 1, because aside from matches, I'm gonna have a record with a circuit from only this table. Do I need a circuit from table 2? I would say no, because again, it's redundant. If we have a match, then it's redundant. If we don't have a circuit, matching circuit, well, then it's null, so it carries no information. So again, I would remove it. Same thing for the right circuit, for the right join, I'm sorry. But if we're doing a full join, then we need to see both. This is what I started with. Right? Because we will have a circuit from table 1 that's not found in table 2, and we will have a circuit for, at least, it depends on the data, of course. You might have two tables that have perfectly matching circuits, and then you get everything with your inner join. But of course, you build a query that will work with, give you the result you want with any kind of data. All right, so I think I covered it in full detail. What else can we say from very basic joins? Cross join, that's the last one I'm gonna cover. So What is this? So this is also called Cartesian product. Basically, we take all records from table 1 and we match them with all records from table 2. And notice there is no on clause, because we are not really matching on anything. There is no comparison. We are literally taking first record from table 1. Let me add order by, it's gonna be much easier to see. So we are taking first record from table 1 and combining it with the first record from table 2. Then for the same record in table 1, we're combining it with second record from table 2, then with third record, and then with fourth record. Absolutely doesn't matter if they match or not. So we're done with record 1 for table 1. Now we're doing table 2 from table 1, matching it with all the rows from table 3. This is why you will always get, in Cartesian product, you'll get the product of number of records in table 1 and table 2. We had 4 and 4, so this is why we get 16 rows. Now, it's not a very useful join by itself, but in the next tutorial I'm going to talk about a little bit about how joins work internally. And turns out for any kind of join that we do, the database first does cross join. So we'll look at it in detail because it's really intermediate step for other joins. All right, hope you enjoyed it.